There's a video circulating online. It shows a sudden flash on the surface of the moon. Some people say it's an alien probe. Others claim something artificial just crashed into the lunar surface. Many viewers were shocked. But here's the part most people missed. This wasn't CGI. It wasn't edited footage. And it wasn't a hoax. Because astronomers actually recorded this event live, using a ground-based telescope. So what is really going on here? And what exactly hit the moon? On December 12th, at precisely 3:09 and 36 seconds Universal Time Coordinated, a robotic telescope at the Armagh Observatory and Planetarium in Northern Ireland recorded a brief flash of light on the moon's night side. The flash lasted less than a second, but its brightness, exact location, and timing immediately set it apart from background noise. What astronomers recorded was known as a lunar impact flash, a short burst of light produced when a fast-moving object from space strikes the moon's surface. Unlike Earth, the moon has no atmosphere. Incoming objects are not slowed, heated gradually, or broken apart before impact. Instead, when something reaches the lunar surface, all of its kinetic energy is released almost instantly. That energy converts directly into heat and light, briefly vaporizing both the object itself and a small portion of the moon's surface. The result is a momentary flash that can sometimes be detected from Earth. Catching one of these flashes is extremely difficult. The impact must occur on the moon's dark side, away from reflected sunlight. The telescope must already be aimed at exactly the right region. And the imaging system must be fast and sensitive enough to register a sudden spike in brightness that lasts only a fraction of a second. Most lunar impacts go completely unnoticed. This one didn't. The Armagh Robotic Telescope is specifically designed for high-speed monitoring. It captures many frames per second and continuously scans dark regions of the moon, searching for sudden changes in brightness. When this flash appeared, it stood out clearly against the background. Follow-up analysis ruled out reflections, sensor artifacts, cosmic rays, and atmospheric interference. The signal matched every known characteristic of a genuine lunar impact flash. This detection is believed to be the first confirmed lunar impact flash ever recorded from Ireland, and only the second recorded from the UK region. That alone makes it notable. But the real significance of this event lies not just in where it was recorded, but in when it happened. The timing of the impact strongly suggests a connection to the Geminid meteor shower, one of the most intense and reliable meteor showers observed from Earth each year. Every December, Earth and the Moon pass through a dense stream of debris left behind by asteroid 3200 Phaeton. This debris stream contains countless small particles moving through space at extremely high speeds. On Earth, these particles appear as bright meteors because they burn up in the atmosphere. The Moon, however, has no atmosphere. Because nothing slows these particles down, they strike the lunar surface at full velocity. In this case, astronomers estimate the object was traveling at around 35 kilometers per second. At that speed, even an object smaller than a golf ball carries enormous kinetic energy. When it impacts the moon, that energy is released instantly, producing intense heat and a visible flash of light. What makes this event especially important is that the object responsible for the flash was completely invisible before impact. It was far too small to be detected by telescopes while traveling through space. Its existence was revealed only at the moment it struck the moon. This is why lunar impact flashes are scientifically valuable. They allow researchers to observe and study a population of fast-moving debris that would otherwise remain hidden. While the timing and estimated speed strongly suggest a Geminid origin, scientists remain cautious. Multiple debris streams cross the moon's orbit, and confirming an exact source requires careful orbital modeling. This restraint is deliberate. Science advances through evidence, not assumptions. What matters most is that this impact provides direct observational data about how often small objects collide with bodies near Earth. And that leads directly to the bigger picture. At first glance, a brief flash on the moon may seem like a curiosity, interesting, but insignificant. In reality, it carries implications that extend far beyond the moon itself. The moon acts as a natural impact detector. Unlike Earth, It has no atmosphere to burn up incoming debris and no weather to erase surface evidence. Every impact, no matter how small, contributes to a long-term record of collisions occurring in near-Earth space. By observing these flashes, scientists can directly measure how frequently small meteoroids strike solid bodies in our cosmic neighborhood. This is critical because most planetary defense efforts focus on large asteroids, objects capable of causing global damage. Smaller meteoroids are far more numerous and still pose serious risks. They can damage satellites, threaten astronauts, and gradually degrade spacecraft over time. Yet many of these objects are impossible to detect before impact. Lunar impact monitoring helps close that gap. By correlating impact flashes with known meteor showers, scientists refine models of the near-Earth debris environment. This improves predictions of impact frequency, particle density, and long-term exposure risks for future space missions. There is also a broader lesson here. Space is not static. It is active, dynamic, and constantly evolving. The moon is still being reshaped today, grain by grain, by ongoing impacts. Perhaps most importantly, this observation highlights how modern astronomy is changing. Meaningful discoveries no longer come only from massive space agencies. With robotic telescopes, automated monitoring, and careful analysis, even relatively small observatories can capture moments that significantly advance our understanding of the solar system. This flash was not just a visual moment. It was a data point, a confirmation, and a reminder of how much is happening around us, even when we're not looking. A split-second flash on the moon may sound simple, but what it reveals is profound. It shows that the space around Earth is active and constantly changing, and that even tiny pieces of debris can teach us important lessons about the environment we live in. With the right tools and curiosity, scientists can witness these processes unfolding in real time, hundreds of thousands of kilometers away. If you enjoy this video, don't forget to like and subscribe for more space updates. Your support helps keep this journey going. Thank you for watching, and see you next time.